Hello there, welcome to lesson number 6 in our series on using FluidDesigner for 3D printing to create rings. Today's lesson we're going to show you how you can create a wireframe torus ring. So if you start FluidDesigner up, we're doing rings, so it's learning projects, jewelry projects, rings. We're doing lesson number 6, so if you drag and drop 06 wireframe torus ring onto the desktop, that's what you should get. Now, as is usual, the instructions are all in the help window over here, and essentially we're just going to use a mesh, a torus mesh. Now, it's very important that the toolbox is open here because we're going to change some properties in the toolbox. So if this window is not open, if it's like that, you can just press T on the keyboard for toolbox to open it up. So what are we going to do? We're going to go to add mesh and we're going to add a torus mesh. And as I've said, we do want this panel open here, and I'm just going to pull it up a little bit more because the parameters that we want to change are actually the parameters at the bottom, not so much the ones at the top here. So if we go to view and zoom to selected, there's our torus, and what we're going to do, if we look at the instructions in the help panel, we're going to set the major segments down to 12. So they start off at 48, so let me just move it right down. And just to remind you, if you haven't done this before, the major segment, I mean, I've moved it right down to 3 instead of 12, just to explain what major segments are. The major segments are the number of the segments around the outside. So 1, 2, 3 segments, they're the major segments. 1, 2, 3, 4. 5, 6, 7, 8, 9, 10, 11, 12. So by setting the major segments at 12, we've got 12-sided shape there, 12-sided ring, and notice because of that it's not exactly 100% round in the middle, so we're going to have to size it up in the middle carefully afterwards. Now, because we're creating this wireframe, we're going to set the minor segments down to 4. So I'm just zooming back in here. Now the minor segments are the number of segments around this direction. Major segments is the circuit around the outside of the entire object. Minor segments are the number of segments here. So if we set it down to 4, what we've got is we've got one segment there, one segment there, one segment there, that's 3, and then another segment there, that's 4. So there are 4 segments around it. So this gives us a very chunky object to work with. Now the next thing we're going to do is we're going to change this Torus Dimensions option here from major minor to exterior interior. So we're going to use the exterior and interior radii for the Torus Dimensions. So you see that these change. So if we've got major, it says major and minor here. When we select exterior, interior, these change. And what we're going to assume in this instance is that we are going to try at the moment to create a ring which has got an interior radius of 10 millimeters. In other words, the internal diameter should be 20 millimeters. So if I type 10 millimeters for that, you'll see that my object changes. It looks a bit odd because I need to change the exterior radius as well, and I'm going to change that to 11 millimeters. Okay, so if we look at this object now, what have we got? Well, the interior radius is 10, so the distance from there to the inside of the object is 10. So this diameter should be pretty much 20 millimeters. Now, not going to be quite like that because of the shape of this object. It's not fully rounded, but it gives us an idea of the size. Now, the 11 millimeters, well, the 11 millimeters is to the outside. So in other words, the thickness of this object is 1 millimeter. So we've got 10 plus 1 is 11. Same on the other side, hence we get 22 millimeters. And because this is 1 millimeter thick, we get a Z value of 1 millimeter. Now we want thickness bigger than 1 millimeter for the ring, so in other words the width of the ring as it sits on your finger. So we're going to change this to 6 millimeters here in the properties window. Now whenever you resize in FluidDesigner, you must always go to Control A on the keyboard and apply the scale. Otherwise you're going to have problems when it comes to printing. Okay, so that's what you must always do in FluidDesigner. Now we're going to try and create a wireframe ring. So what we need to do is use a wireframe modifier. So in the properties window we go to modifier icon, that's the spanner, and we're going to go to the wireframe modifier. And the settings that we want are the default settings. Quite often the case when working with the wireframe modifier, you leave the thickness as quite small. We're going to have the offset as 0. So in other words, when we apply the Solidify modifier, volume will be placed on the inside and the outside evenly. And we're going to tick even thickness as well, to scale the offset to give more even thickness. Now clearly we can't print this object, it's got really no volume to it. Okay, it's far too thin to print. And so what we need is a Solidify modifier. And we're going to set the thickness of the shell to be 1 millimeter. Now if we zoom in on this object, what you should notice is that there are some strange bits and pieces here that are essentially bits that are sticking through from the back. Yeah, the way this is being created, we started off with a wireframe and then we've added some thickness to that. You get an unevenness sometimes when using this feature. And the way to try and solve this is to vary the offset. Now at the moment the offset is at -1. If we change this, and I'm just dragging the mouse to the right so you can see what's happening, you'll see as I get up to +1, the strange bit of the object, the bits that are protruding through, disappear. So if I go back down again, you'll see these are the bits that are protruding through. We don't really want it looking like that. We want it as smooth as possible. So what we find is if we go to +1, that smooths off the mesh there. Okay, and you can only do this by looking at the object and playing around with it and seeing which values are the best given the size of the object and given the values you've got up here as well. Now you can try ticking other things. For example, if you tick even thickness here, that's something that happens quite often. It goes really strange on you, so you need to remove that. You could try ticking high quality. That doesn't appear to make much of a difference, certainly not from viewing it out there. Okay, so that's what we're going to do. We're going to thickness 0.02, offset 0, tick even thickness, thickness of 1, offset of 1. Now we need to apply these modifiers, and we do that in FluidDesigner by going to Tools, Object, Tools, and converting it to a mesh. Now if we just delete the original object by pressing X on the keyboard and deleting it, we can have a look at what we've created in this lesson. And if we view it from the top, now the internal diameter, we tried to set it at 10 millimeter radius, which would be 20 millimeters internal. That's what we tried to set it at. Now if we go to the interactive ruler, because of the thicknesses that we've applied and the wireframe and whatever, you can see it's reduced to 18 millimeters. So if we actually really wanted an internal diameter of 20 millimeters, we need to scale this. Now, you know, you need to consider what size do you want your ring to be when you produce one to fit your finger. You don't necessarily need to make it at 20, but I'm going to do it at 20 millimeters here. And the best way to actually size this is to add a cylinder mesh to the workspace, and I'll just we can change the radius of the cylinder here. Actually, if I set the radius here to be 10 millimeters, that will give me a cylinder that is 20 millimeters diameter. So I've set the radius here in this panel for my cylinder. Now I'm going to give it a bit of thickness as, whoops, I've gone a little bit too high in Z value there, just to, I've just gone up the Z value to 34 so you can actually really see the cylinder. Now we're only using that to scale our ring up. So if we go to view and view it from the top, what we want to do now is to highlight the torus ring, and to size it up, to scale it up, we press the S key on the keyboard, and then we slowly drag the ring out until it just fits outside the cylinder. And then we can click the left mouse button. Now because we've scaled that up, what we must also do is Control A and apply that scale again and reset the scale. Now one of the things about scaling up is that the thickness of these walls will change when you scale up. They will become thicker. If you scale down, the thickness of these walls will become smaller. So you do need to be wary of that if you're using scale. Now I'm going to highlight that cylinder. I don't want that, so I'm going to delete it. So there's my wireframe Torus Mesh now. And so I need to save that, and I'm just going to go to File and always go to Save As in FluidDesigner. Go up through the menu system. We're doing rings, so it's My Projects, Jewellery Projects, Rings, and we can save lesson 06 as a wireframe torus ring as a Blender file. And we can export that to the desktop as a wavefront object. As 06 wireframe torus ring as an OBJ file, and then we always need to go to Netfab Basic and check this. So if we go to Project and Open and go to the desktop, so it's 06 wireframe torus ring, and that's the object file. Now we haven't got any warning red triangles, but always go to Extras and repair the part. Just move it across. And this is a really good sign here. We've got no border edge or orientation or holes. If we'd have left our offset at -1 instead of +1, there's a good chance we could have had some problems here. But we haven't, so we just need to run automatic repair and execute it. And then apply the repair and remove the old part. And everything's looking good, so we just go to Part, export the part as a wavefront object, export it to the desktop, and so the repaired 06 wireframe torus ring object file, that's the file you would send to your printer. Okay, so there's a wireframe torus ring for you. Thank you.